Hello everybody, we're getting ready to do lesson 2.1 part 2 today for 6th grade math. And 2.1 part 2 classwork has 30 points on it. Have your classwork sheet out in front of you now. Put your name, date, period here on your phone, your tablet, your Droid. And this is about greatest common factor, 2.1 part 2. Let's go right into page 1 of today's classwork, finding the greatest common factor. One way to find a GCF, which is short for greatest common factor, of two numbers is to list all of their factors. Then you can identify common factors and the GCF, or the greatest common factor. So let's go into our first example of today's lesson. Example 1. A baker has 24 sesame bagels and 36 plain bagels to put into boxes. Each box must have the same number of each type of bagel. So each box must have the same number of each. What is the greatest number of boxes that the baker can make using all of the bagels, of the sesame and the plain? So how do we figure that out? List the factors of 24 and 36. Then circle the common factors. So for factors of 24, which would be the sesames, we have 1, 2, 3, 4, 6, 8, 12, and 24. These would be the factors of 24. And then the factors of 36 will be 1, 2, 3, 4, 6, 9, 12, 18, and 36. So with that, we can find the GCF of 24 and 36 by what method are we going to use? Here are our factors. So what do we do now? The greatest common factor here is 12. It's 12 of 36 is way up here, and then the 12 for 24 is way up here. So right here is your greatest common factor. 6s are down here. 18 is not common. 9's not common. 8 is not common. So 12 is your GCF for 24 and 36. So the greatest number of boxes that the baker can make is 12. There will be 2 sesame bagels in each box because 24 divided by 12 is 2. So remember, we got 24 of the sesames, so we can only have 2 sesames per box. And then the 3 plains, because 36 divided by 12 is 3, so we'd have 3 of the plains and then 2 of the sesame. Okay, what do we just do? Critical thinking. What is the GCF of 2 prime numbers? Give an example. So greatest common factor of 2 prime numbers. Students, can you think of any? Teachers, students, think of some. Stop the video and write down some ideas in here, or we're just going to go right to it here. 1, for example, the greatest common factor of 11 and 13 is 1. So what is the greatest common factor of 2 prime numbers? Give an example. 11 and 13 are prime. The GCF of 11 and 13 is 1. How about that? So now, students, this is all you. Find the greatest common factor of each pair of numbers. What's the greatest common factor of 14 and 35? Teachers, give your students about 1 minute. And then after you give them 1 minute, it would be 7. Your factors of 14 are what? 1, 2, and 7. And then 35 would be 1, 5, and 7. And so 7 would be your greatest common factor for these 2 numbers. Page 5. Again, another your turn. The 6th grade class is competing in a school field day. There are 32 girls and 40 boys who want to participate. Each team must have the same number of girls and the same number of boys. What is the greatest number of teams that can be formed? How many boys and how many girls will be on each team? So here is a good question here about putting the same amount of boys and girls on teams. How many boys and how many girls will be on each team? Teachers, give your students about 5 minutes for this one. 2 points for page 5. And then stop your video, then restart it again. And for that, we have 8 teams. We'll have 8 teams with 4 girls and 5 boys. 32 and 40, our greatest common factor between 32 and 40 would be 8. And then we divide 8 into 32 and the 40, and we get 4 girls and 5 boys. That would be the quick answer for that one. Let's move on to explore activity using distributive properties. So this distributive property you're going to be using for the rest of your mathematical career. You can use the distributive property to rewrite a sum of 2 or more numbers as a product of their greatest common factor and a sum of numbers with no common factor. Okay, 2. Understand how you can use grid papers. We're going to get some graphing paper, students, to draw area models of 45 and 60. So we gotta, well, we'll get into it. Here are all the possible area models of 45. So for 45, drawing an area model, you could have 1 unit down, 45 units across. You could have 3 units down and 15 units across. You could have 5 units down and 9 units across. All of these would work because they're all factors of 45, right? 1, 3, 15, 45, 5, and 9. They're all factors of 45. And then for what do the side lengths of the area models 1, 3, 5, 9, 15, and 45 represent? What do they represent? I think I just said it. They're all factors of 45. So we can kind of understand these numbers a little bit better by using area models. And then part B here, on your own grid paper, show all of the possible area models of 60. So for an area model of 60, on this grid here, show all the possible area models of 60. Teachers, give your students about 3-4 minutes to do that on this grid here. And turn off your video, give them a shot, and then turn it back on, and we're back to check your students' work. So teachers, check your students' work, and then students, put your area models here, and then turn it in with your classwork, and I'll check it. So moving on here to page 9, we are going to find the side lengths of area models of 45 and 60, and what do they have in common? What do the side lengths represent? Again, for area models of 45 and 60 here on your grid, put those on your grid. That might help you. Part D, what is the greatest common side length of 45 and 60? What does it represent? And then part E, write 45 as a product of the GCF and another number, and then write 60 as a product of the GCF and another number. So teachers, give your students about 5 minutes to fill these in. Turn off your video, give them 5 minutes, and then welcome back. 1, 3, 5, and 15 are the common factors of 45 and 60, 1, 3, 5, and 15. And then what is the greatest common side length? What does it represent of up here, 1, 3, 5, and 15? The greatest, the common side length would be 15. 15 goes into 45 and 60. It is the GCF of 45 and 60. And then write 45 as a product of a GCF and another number. So 15 goes into 45 3 times. And then 15 goes into 60 4 times. So there you go. There is your GCF and another number. And that is for GCF for 45 and 60. Use your answers above to rewrite 45 plus 60. So 45 plus 60 also equals 15 times what? and then plus 15 times what? So we have 15 times what plus 15 times what will equal 45 plus 60. Students, what would that number be? 45 and 60 will be 105. So what times 15 plus what times 15 would equal 105 is the question. Use the distributive property in your answer above to write 45 plus 60 as a product of the GCF and a sum of two numbers. So that's pretty cool. So if you do that, you have 15 times what plus 15 times what equals 15 times something plus something, and that would equal 15 times 7 would equal 105. So what plus what equals 7 is the question. So we have 3 and then we have 4. So if we plug in 3 and 4 here, won't we get 7? So 15 times 3 plus 15 times 4 equals 15 times 3 plus 4 equals 15 times 7. That's your lesson for today. Animated PowerPoint math video at alo.com for questions or course materials. Thank you very much.